Well, here we are for another Monday morning video. I'm a little late getting this one done because I had some other stuff I had to do first, but I prepared this one last week. This is telling the story of something I fixed a few years ago, but I had all of the stuff down pat in the pictures, and also here we go. You know, I stopped at help stranded motorists sometimes, have for years. There's not a lot of serial killers and axe murderers in rural Alabama that I've ever seen, so it's still pretty safe. I wouldn't recommend anybody else do it, but you know, sometimes I help people. I've seen them beside the road with just with pouring gas in a carburetor that had a stuck choke, trying to get it to start, you know, and sometimes it's loose connections and just one thing and another, you know. Flat tires are fairly common. You'll see somebody out there trying to change a flat tire and they don't have a clue what they're doing, and so I got to take my little pump jack out. The coolest thing I ever did recently was I've got this 20-volt DeWalt impact wrench with a set of lug sockets, and I can change a tire once I get it jacked up in about 90 seconds. You know, it's almost like a not really a pit stop because they do that in about 10 seconds, but anyway, it's a whole lot easier if you got that strong DeWalt impact wrench when you're changing a tire. You can get that thing jacked up the less time you spend changing the tire, and it's obviously when you're fooling with the lug nuts and all that kind of stuff, you know, it's going to take more time if you don't have power. Anyway, that works pretty good. The irrigation engine now by the pond, that story, this guy, farmer I'd known for all these years, came and knocked on the door and everything. It was this guy's dad, and he knocked on the door and he said, can you help me get my irrigation engine started, because it hadn't been started. This was like in 1983, and he woke me up on a Sunday morning, and so I drove with him down to the pond on his little Ford Courier pickup truck, and we chased the wasps and the rattlesnakes away, and I put spark plugs, and it was like a Oldsmobile 455 or something he had hooked up to the irrigation pump, and it had been sitting there, and the cylinder walls had, you know, were dry, and it was spinning slow. Had a good strong battery, but it was just so I hooked it up 24 volts and got it spinning up and busted it off. And you can't do that on one of the electronics on it, but that thing had points in it. One way or another, got it started, squirting water everywhere. He took me back home. It took us probably an hour and a half, 2 hours to get all this nonsense done down there. And I charged him $20, and it kind of made him mad. Of course, I put it in the offer and played at church anyway, so it didn't really matter. Anyway, I don't want to get lined out on that story. This particular one here, this is a picture of the truck. My son owns this truck now. My uncle bought this truck later, and then my son bought it, so my son drives it now. But it was less than a year old when my friend bought it. He had driven it until it had lots of miles on it, relegated to a farm truck his wife used. It would stop running without warning and make strange noises under the hood after it quit. And I was asked to have a look at it one afternoon when I was off work. So his wife said, when I try to drive it to the chicken houses, it just quits on me. I hadn't driven it in a couple of months. The battery's probably dead now. Well, the battery was new, but it was dead. Okay, so I didn't expect to find a problem with the tools I carry with me, but I thought maybe I'll buy the truck if the money's right. I wanted to get a handle on what might be wrong with it. Still a decent old truck, you know. Well, with the jumper cables hooked up, the truck started easy, and it ran well for about 90 seconds, and then the engine stalled, and I could hear buzzing over near the master cylinder where these relays were, and where the EEC power and fuel pump relays, you know, that's EEC. This is EEC power, that's fuel pump relay, and that's the air conditioner relay, which basically it has the normally closed contacts on that particular relay, keeps the air conditioner compressor powered up, unless you go wide open throttle, and then it energizes the relay and drops the air conditioner out. Anyway, the long and the short of it was all that's just buzzing to beat the band over there. Well, I found that the powertrain control module was firing an oscillating ground into the control side of the fuel pump relay coil from pin 22 on the 60-pin PCM. Now this is pin 22, that goes to the test connector under the hood where you used to hook up your scan tool or get your codes to flash out. And then this right here is what energized that relay. Okay, so what you got here, let's look at how this circuit works. I'm going to turn that switch on, and you're going to see these two relays turn on. Alright, so I turn on that switch, and everything you see in red is powered up, and there's current flowing there. This is going through the inertia switch to the fuel pump. The fuel pump relay though was buzzing back and forth, something awful in this particular case. It wasn't. This is how it's supposed to work. Okay, and so all of that, this power relay puts power out to every solenoid that's controlled by the engine controller, which would be your fuel injectors, not the ignition coil because it's fed directly from the ignition switch. The fuel injectors, the transmission solenoids, anything that's controlled by the engine controller is fed by the power relay on this old 91 F-150. And you got them fuse links up there, Alright, so maybe it's a loose ground, I thought. Well, that ground looks terrible. And I said, well, I've seen it do some weird stuff. How many times you ever, in the early days, where you have some, I can't figure out what's wrong with this, so it must be the computer. I think I'll just throw a computer at it. I don't know how many people have gotten in trouble that way. And or how many people I've heard tell me, well, I put the computer in there and that didn't do no good, all this stuff. So, anyway, fix the ground. I pulled the ground wire, the buzzing would stop and then changing its pitch and frequency. Well, I screwed the nut off the stud, then screwed the stud out of the radiator support. I worked that thing down, I got it all polished up and I got it all tightened up. I didn't take a picture of it after I did that. But you can see how that was something that needs to be handled. Alright, when the engine started and ran about 5 seconds before it stalled again after I did that, then the buzzing kept on going. So, well, I thought I'd fixed it, but no, I don't think so. Battery was still as dead as a hammer. I could perform some tests with my jumper cables to determine if there was a ground problem somewhere else. What I mean by that is you take your jumper cables and you just one side of them, you hook it up to the ground side of the battery, and then you can hook it to the engine block or wherever else you're trying to make sure that, if you could provide a bypass ground, you can a lot of times straighten it right on out. If that's what the problem is, then you know what you need to do. It didn't do any good here. 20, 40, 60, 16, and 49 are grounds on these old 60 pins. Now that was a little bit of a change. 16 is ignition ground. These are main grounds. A couple of them goes to the battery. One of them actually, I think 20 goes to that shield around the pip wires and all. And so, but anyway, 49 is not there on the ones that have a 4-wire oxygen sensor. So this is an oxygen sensor ground right here. So you need to be aware that you're always going to have these in that one, but this one right here, and that's on the 60-pin engine controller that was, before everything went OBD2 in the 90s, which was the earliest OBD2 that Ford had was the Thunderbird, and it came out in 94, but everything was, except 1-ton trucks, was OBD2 by 98, and then by by 97, and then by 98, everything was OBD2. Well, disconnect the fuel pump relay connector. I discovered there were other components buzzing as well. So when I unplugged the fuel pump relay so it wasn't buzzing anymore, I could hear other things buzzing. The thermactor air bypass and ignition coil. The ignition coil was buzzing, and these two solenoids right here are your tab and tad, thermactor air bypass and thermactor air diverter. So I glanced at the tachometer and the instrument cluster, and I saw it reading 800 RPM when the engine wasn't even running. So that's because the coil was getting a signal to fire on there. So with the engine dead, it's reading 800 RPM, and I'm hearing this buzzing. This is crazy. So this is the TFI system, the solid state PCM here. This is how all this stuff hooks up. There's your TFI module. It's mounted on the side of the distributor on this one. There's your IDM resistor. That one there basically just tells the engine controller whether the coil is firing or not. It's not too hard to figure out what that's for if you know what you're looking at. And then there's your radio noise capacitor that's supposed to absorb any, RFI that's going to cause the radio to buzz. Then this goes to the ignition. Now this right here is going to be, a lot of these Fords would have a resistor wire right there, but this one doesn't. It pretty much goes straight to it. Alright, now then, this is what it looked like when you had it in your hand. This is actually on that truck I was working on. There's your spout connector right there. I pulled this plug out of here. That's just a jumper plug is all it is. You're supposed to pull it when you set the timing, so it keeps the computer from jacking around with the timing, and you can set it on 10 degrees before top dead center. I turn in the distributor. I pull that because a lot of the times if you pull that, there will be issues. There's another story I could tell you about an Aerostar. I went down to Graceville, Florida, to the Ford dealership down there, and they had a brand new Aerostar, the 88 or 89 model, that had quit running about a week after the people got it. And the mechanics down there had just busted their rear end trying to fix it. They put a distributor in there, a TFI, all this kind of stuff, and they couldn't get it going. And so the guy called me from the up there where I was working, and he says, "Can you come down here and look at this? I'll make it worth your while." So it took me a couple of hours. I drove down there. Basically, the trip down there and back took a couple of hours. It took about 90 seconds to get the van started. On that particular one, all I did was pull a spout connector. Suddenly we had spark and the engine started up. And it needed an engine controller because it had the spout shorted. If this circuit is shorted to ground or power on these old TFI equipped Fords, it will kill the ignition system completely. Alright, that's PIP, spout, start, run, coil, and ground in that order. And so I just made sure that you had a good picture of that. With the PIP wire pulled back from out of position and the TFI connector, you know, an older one, this was a blue wire, but on this one is orange, gray with an orange stripe. The TFI module stopped firing the ignition coil when I pulled this back, when I disengaged that from the terminal in there. The thermactor air bypass was still chattering away. It was still buzzing up a storm. Alright? So the Renegade signals were all coming from the PCM on unrelated circuits. These are the three circuits it was coming on. The PIP was going to the tab, and it was going to the fuel pump relay. Those three were the ones that were firing just as fast as they could fire. The problem appeared to be within the PCM itself. Now that's a kind of a bad bet. You know, you go to the parts store, back in these days when everything's plug and play, you could go to the salvage yard with a number off of your engine controller, and the interchange guide would tell you which ones would work in most cases. And the salvage yard would even take it back if you got one you didn't need. But anyway, parts store wanted about $100 for it back then. The OBD1 PCM's plug and play, no programming required, no PATs. They didn't come out until several years later. The owner's father had another 91 F-150 with the same engine and transmission, so should we plug the good truck's PCM into the bad truck? Would that be a good idea? No, it would not. Because then, if you plug if there's something wrong with the crippled truck that fried the engine controller, and you plug the engine controller from a good truck into the crippled truck, you may brick the good truck's engine controller. So how do you do that? What you do is you take the engine controller that you suspect is bad, plug it into the good truck, because you're not going to hurt the good truck. You're not likely to, or back in this model you weren't. So what I did was, his dad's truck looked just like this. This is still a picture of that other truck, A and B. I pulled the engine controller from this truck, and I put it on that truck, and as soon as I plugged it into that truck, it was just buzzing up a storm. It was terrible. And I said, that's what's wrong with the truck. It needed an engine controller. And so I went and got a $100 engine controller from the parts store and plugged it in, and that engine controller is still on that truck today. This was a long time ago. I think I did this job in that 2006 or something. I don't know, but anyway. All right. Question number 1. Keep alive power is necessary on vehicles, modern electronics for what? A. Scan tool communications. B. Retention of volatile memory data. C. To provide deep cycling of the vehicle battery. D. Keep alive power isn't necessary. We're going to come back and give you the answers to these. Technician A says all sequential fuel injection systems use a chem sensor for injector timing. Technician B says the 91 F-150 5-liter has sequential fuel injection. Who is correct about that? Okay. Technician A says all fuel injection systems use a switched ground to fire their injectors. Technician B says the injectors on high-performance engines usually have more resistance than lower performance injectors. Who's correct about that? Question 4. Technician A says on a distributorless ignition system, an open spark plug will cause 2 cylinders to misfire. That's the one where you got the distributorless ignition system where you got one coil fire and 2 plugs. All right. Technician B says there's no internal wiring connection between the primary and secondary windings on a distributorless ignition coil. Technician A says the thermactor air system can malfunction and cause the fuel injected vehicle to run rich. Technician B says the thermactor air system can cause a fuel injected vehicle to run lean. Who is correct about that? The main ground connections on an EEC4 engine controller are pins what? 37 and 57, 36 and 37, 20, 40, 60, 16 and 49, or 49 and 37. Question 7. A 99 Pontiac Grand Prix comes in on the hook. A quick Noid light check reveals that none of the fuel injectors is firing. The scan tool data stream shows an RPM signal. Technician A says the ignition module is probably bad. Technician B says the ignition module isn't likely to be the problem. Who's correct about that? Technician A says shop manual pinpoint tests always lead to the source of the problem. Technician B says it's smarter to try a bad computer on a good vehicle than the other way around. Technician A says the test light should never be used when troubleshooting electronic control systems. Technician B says the presence of voltage on an unloaded circuit doesn't mean sufficient amperage is available to operate the circuit. A service engine soon light concern is being checked. Long fuel trim readings are at -12 on both banks. Short fuel trims are near zero. Technician A says changing the engine oil may correct this concern. Technician B says both oxygen sensors may be faulty. Whose idea should be pursued first? Alright, let's go back. Alright, keep alive power is to retain non-volatile memory data. You know that the adaptive learning, like for your idle air control, your fuel trims and all of that, needs to be held on to. If you shut it off and kill that keep alive power every time, turn it back on, it has to relearn. I don't know how many times you've had to put a battery in something like a Dodge pickup. After you put the battery in the Dodge pickup, it wouldn't idle. Because it's a little bit of a dirty throttle body or whatever, and you had to wash the throttle body out and let it start over like it was new. So adaptive learning does a lot of different things. It does a lot more than fuel trim. It actually works with idle speed control too. So basically this one here is the retention of volatile memory data is the right answer. Technician A says all sequential fuel injection systems use a cam sensor for injector timing. Technician B says the 91 F-150 has sequential fuel injection. Who's correct about that? So heck, A, B, both or neither. Alright, now all sequential fuel injection systems use a cam sensor for injection. That is mostly true, and the reason I'm saying that is because if it doesn't have a cam sensor on the camshaft, it will actually have one, like for instance this one here even, is a profile ignition pickup. One of the windows in the little hall cup in that distributor is narrower. Well, actually it's a wider window but a narrower vane, and that's how it knows where number one is. But on this particular truck right here, in spite of the fact that it's got that, the 91 F-150 on this one has bank fired injectors. So it's actually firing 4 and then the other 4 and 4 and then the other 4. That's not really good for gas mileage or emissions, but that's the way it was done. On your Chevys that have a sequential CSFI system, if somebody puts the distributor back in on that one and they get the cam sensor to where it's unreliable and the engine controller can't trust it, it bank fires those injectors and the fuel economy goes to crap. And so just keep that. You got to set the cam retard offset on one of those. We talked about that on a previous video. Technician A says all fuel injection systems use a switched ground to fire their injectors. Technician B says the injectors on high performance engines usually have more resistance than lower performance injectors. Now you might notice pins 58 and 59 on this one are firing. It's got 2 pins that are firing all 8 injectors on that one, and that's from that 91 model. Anyway, all fuel injection systems don't use a switched ground. It's very rare, but some of them will actually switch to positive side. The one that comes to mind that I'm familiar with was from 87 to 90 model Jeep Cherokees, fired the positive side of the injector, switched the positive side of the injector to the ground. They were hardwired to ground and the positive side fired. Usually the negative side's what's fired though, because it makes less RFI, and it's a little easier on the drivers, but it'll work either way. Technician B says the injectors on high performance engines usually have more resistance. Nope, that's wrong. They'll have less resistance because they want them to operate faster. Like I said, if you've got a really high performance engine, you'll have, if you want speed and you want that thing to work really crisp, you're going to have lower, like an injector on one that's not high performance will usually have 16 ohms or something like that. Some of the supercharged engines may have 2 or 3 ohms or whatever. But if you put one of those 2 or 3 ohm injectors on where a 16 ohm injector is supposed to be, and you're going to overheat the driver in the engine controller and cause it to shut down. Alright, Technician A says on a distributorless ignition system, an open spark plug will cause two cylinders to misfire. That is not true. It will still fire the other one. Now, in the early days of distributorless ignition, the instructors used to try to act like, since it was an open circuit, it was only going, if you unplug one of them, the other one won't fire either. That's hogwash. It's going to find a way. And I've seen that personally too many times, where just one tower went dark and the other one was firing, you know. Technician B says there's no internal wiring connection between the primary and secondary winding. That is true. So this guy right here is Technician B is right, Technician A is wrong. Technician A says the thermactor air system can malfunction and cause the fuel-injected engine to run rich. That is true. The way it does that, if it malfunctions and it sends oxygen down there to the and ahead of that oxygen sensor, I know some of it can do that. It will actually cause the oxygen sensor to report a false lean condition, and it will increase the pulse width, and it will cause it to puff out black smoke. As a matter of fact, when you're going through your self-test, in order to check the thermactor system, the controller will dump air upstream of the oxygen sensor and watch for it to go lean. That's just one part of the strategy on that. Technician B says the thermactor air system can cause a fuel-injected vehicle to run lean. That's not typically going to happen. This one here is very common. I'd say this guy's wrong. The main ground connections on an EEC 4 engine controller are 20, 40, 60, 16, and 49. Remember, 49 may not be grounded on some of them, because if it's got a 4-wire oxygen sensor, you know, the ground may be going to the, well, on one of them, the ground goes to the engine block instead of, but the later ones, I think, go to the engine controller, come to think of it. The earlier ones went to the engine block for the oxygen sensor ground, but the later ones actually went into 49. One way or another, 49 is the ground for the oxygen sensor, and these other three, that's ignition ground, and these other three are your main engine controller ground. He uses those to fire injectors and stuff and close solenoids, by the way. 99 Pontiac Grand Prix comes in on the hook. Noise light check reveals none of the fuel injectors is firing. The scan tool data stream shows an RPM signal, and the ignition coil is popping. I didn't say that on that question before. So I actually saw this when I stopped by the Chevrolet place. Technician A says the ignition module probably bad. That's not true, or you wouldn't be having a good RPM signal and coils firing. The ignition module isn't likely to be the problem. What we found on the one that I saw over there, there was a relay that was actually powering up these injectors on that Pontiac that I went to look at, and that relay was a bad relay, and it wasn't turning the injectors on, so the engine controller couldn't fire them because there was no power at the injector. That wasn't really too hard to track down. There was another time I went to that Chevrolet place over there. There was an old 94 model truck somebody had put MSD ignition on, and the guy that owned the truck didn't want MSD ignition anymore. He wanted it put back like it was supposed to be. So they ordered the parts, and they put the original distributor back in it. They put it all together. They plugged in all the wires and got it like it was. It would not fire that coil. Absolutely wouldn't fire it. And so while I was over there one day, hey, can you look at this? I said, yeah, I'll come out and look at it. So the first thing I wanted to do was determine whether the module was actually able to fire the coil. Now, you can actually do that if you know how to do it. If you ground the distributor, if you unplug the pickup coil from the module and you have it plugged in where it'll fire the coil, you can actually touch the positive battery terminal. I always lick my fingers just to make sure I got a good connection. And then you tap the side of the module that comes from the pickup coil, it'll fire the coil if it's able to fire the coil. Well, the one I was checking there didn't do that. And I noticed the little pink and white pigtail, about this long, it goes from the ignition coil to the distributor. It's got a pink wire and a white wire, and if you look at the connectors, they're marked A and B. What happened was, whoever built that harness, and it was a brand new harness they got out of the parts pipeline at Chevrolet, that thing, the A and the B were matched up. A was going to A and B was going to B, from one connector to the other. That won't work. A has got to go to B on the other connector, and B has got to go to A on that connector, so that they got to be transposed. And when we got one off of another truck, that's what we found. And when we plugged that one in, it fired up and ran. And so that was just really tricky. See, their problem was they got everything out of the parts pipeline, including the distributor and all that other stuff. They was trying to figure out what part of it was not working right. and it just so happened it was the simplest part there, you know. And so anyway, that's an interesting little story there. Technician A says shop manual pinpoint tests always lead to the source of the problem. Anybody that's followed one of those knows that's a bunch of nonsense. Technician B says it's smarter to try a bad computer on a good vehicle than the other way around. This guy's right, this guy's wrong. Technician A says a test light should never be used for troubleshooting electronic control systems. If you're somebody that knows what you're doing, you can use a test light anytime you want to. But I mean, any dum-dum knows that you're not going to check a TP sensor signal or anything, or any of your low voltage signal with a test light, because it's pointless. And I used test light for 25 years. I ain't ever burnt nothing up. But a lot of these other people, the instructors used to say, oh, don't use a test light. You'll destroy something. You'll burn the computer up. You'll do this. And, you know, that may be true on some vehicles. I never ran into that, though. You know, some people got so crazy about not using test lights, or maybe using a really high impedance test light. I got one of those, but that thing will lie to you like you won't believe. It'll tell you, it'll light the light when there's not even enough current there to pull the load. You know, if you've got the circuit unloaded. Technician B says the presence of a voltage on an unloaded circuit doesn't mean sufficient amperage is available to operate the circuit. That is correct. If you check with a voltmeter, you may see good voltage, but when you load that circuit and try to pull any kind of load with it at all, you wind up with a circuit that doesn't work. So a test light's pretty good. Now this test light here only pulls about 1/4 of an amp. And if the load you're looking at, which is something like a headlight or whatever, is going to need, you know, pull 4, 5, 6, 7 amps, you need to test it with something that pulls about 4 or 5 or 6 or 7 amps, however many amps this thing pulls, or you'll wind up going around in circles. So basically you just you dig in hard and you say, I'm going to take something that'll pull just as many amps as this load, and I'm going to check the ground that feeds this load, and I'm going to check the power. We're going to see if it'll pull this, because if it'll pull this, it'll pull that. That's how you do that. Question 10, service engine soon light comes on. Long fuel trim readings are -12. Short fuel trims are near 0. Technician A says changing the engine oil may correct his concern. He is right. It's subtracting on both banks. And one of the things that they used to tell us when I was working with Ford, if you've got a code, a rich code, what they want you to do is pull the PCV valve out, stop it up with a piece of tape or cardboard or whatever, and then put your finger over the crankcase and see if that causes it to go back into the normal range. If it does, the fuel is contaminating, the engine oil is contaminated with fuel, you know, possibly because of the oil hadn't been changed in a long time. If somebody goes a long time without an oil change, it'll slowly contaminate the engine oil with fuel. And whenever it does that, you'll wind up with the PCV system will pull gasoline vapor in there, and it will cause it to, you know, out of balance them things. This guy, right, both oxygen sensors aren't going to be faulty. You know, you're not going, I would not go there until I make sure everything else was right. It's kind of like changing the engine controller, you know, unless you've got a code that's pointing at a slow oxygen sensor or something like that. I hope you really enjoyed this one. I love doing these things, and every now and then, incidentally, I'll get a trash comment from somebody, you know, that's just trying to stir up trouble. And, you know, I'm not hard to get along with, but since this is my channel, I don't have to put up with that, and I usually just remove those comments and mute whoever that is. Of course, you know, sometimes I can tell if somebody's got a legitimate concern. If I'm wrong, or if I'm said something wrong and they're calling me on it, I'll say, oh yeah, you're right about that, I messed up, because there's not anybody that doesn't mess up. But this particular PowerPoint presentation is over, and I really appreciate you watching it. We'll see you next week, Lord willing.